Alright, so this video is going to talk about scatter plots and line of best fit, and just line of best fit. So it's covering, for some of you, 2 homeworks, for some of you just 1 homework, and that's what we're going with. So these first problems, they give you a scatter plot, and remember, a scatter plot is to see, is there a connection between, the 2 variables, okay? So to draw a line of best fit is basically just us kind of taking a guess at what an average line, a line that would go in between all of these points, what it would look like. Okay, so we need to know the y-intercept of it, so where should we start? Well, if we kind of look at this graph, it's kind of following some sort of pattern like that, right? So we want a straight line, so maybe I could start it right there. I would call that maybe 125. So then my line, I want to try to make it straight, may cut in between those. Okay? So, if I'm thinking about my line, I know my y-intercept is 125. Okay? I chose that point, so 0, 125. And we want to figure out a slope. Now it looks like at 2, we go up to 150, right? Pretty close to that. So what's that slope? So I went up 25 and to the right 2. So it would be 25 over 2. Right? You can just go 150 minus 125, 2 minus 0. Can't simplify it, so that's my slope. So I'd go y equals 25 over 2 x plus 125. Okay? So now it wants us to use this line of best fit to kind of predict what's going to happen. So it says, predict the height of a new roller coaster built in 2012 using your line of best fit. Okay, now the way they label this is they say years after 1988. So that's 1988. So at 2 would be 1990. Okay, then 2 more, 92, 94, 96, 98, 2000, 2002. Okay, so we need to go to 15, 16, right, 15, 16, 17, 18, 19, 20. So that'd be 2002, 16 would be 2004, 2006, 2008, 22 would be 2010. So at 24, where x is equal to 24, that's where we'd be at 2012. So using my equation, I can actually put 24 into my equation to solve for it. And that's why having that line of best fit is helpful. Okay? So 2 into 24 is 12. So what's 25 times 12? You get out a calculator. So 25 times 12 is 300 plus 125, 425. So what that is telling me is that according to my line of best fit, in 2012, my height is going to be 425. Okay? So then it says, predict the height of a roller coaster that was built in 1998. Well, if we look at where it was 98. So 90, 92, 94, 96, 98. If I look up, it looks like it's about 285 maybe, something close to that. So we use that line of best fit to help us predict what's going on. Okay, so the next one, same idea. Okay, we've got those points, kind of seeing that line. So if I'm looking at my line, maybe I want to start at 250 and kind of draw my line something like that to try to match that data. Okay, so my y-intercept was 250, so the points I've got, 0, 250, that's my y-intercept, and then where's another good point to use? Okay, maybe right about here, 25, 1250. Okay, so what's 1250 minus 250, my y's would give me 1,000, over my x's, 25 minus 0, so 25. So it'd be 1,000 divided by 25 simplifies to a 40. So my slope is 40. So my equation, f of x equals 40x, my slope, plus my y-intercept, 250. So then it says predict the out-of-pocket cost, so 35 years from the graph in 2015. So that 35 is right here. How high is mine going to be? Well, I plug this in. This is like the x value, and the cost would be like the y value. So I go f of 35 equals 40 times 35 plus 250. So I go 40 times 35, which is 1,400 plus 250, which gives me 1,650. So, according to my prediction, that's how much it's going to cost annually. Okay, then why are some reasons why healthcare costs increasing so rapidly? Well, you can figure out some of those on your own, but we're not too worried about that question. Okay, now on this one, it wants you to make a scatter plot. So it says using the x-axis for waste generated, so that's going to be waste generated, and this is going to be waste recycled. Okay, and so you've got your data here. So these are your points. So you're going to plot each of those points. Don't worry about the years. Okay, so it's in millions of tons. So you need to figure out how you're going to scale your graph. So these ones, we go up into the hundreds. So we may want to count by, so 0 here. So waste generated. 122 is where we start, to 208. So they're pretty close together in that sense. So probably the best thing to do on this one would be to maybe start at 100, and we'll just, if you make a little line like that, it's like your graph has got a spot missing. So if we start at 100 and then go 110, 120, 130, 140, 150, 60, 170, 180, 190, 200, 210. That should be good enough to get all our information. Then for waste recycled, we start at 9 and go up to 56. Okay, so maybe if we count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And then you can graph them. Then you can graph those points to make that scatter plot. So 122, 9. So 122 up to 9 would be somewhere right there. And they may not be exact. 152, 15. So 152 up to 15. Okay? And so you make your scatter plot, plot all these other points. Then it's going to ask you some questions about line of best fit and all that. So just fill it out. Okay? I think you should be able to get the rest of it down. Alright, now for this other homework, some of you may or may not have. So if you don't worry about it. Okay, so linear and exponential. Remember, linear was that arithmetic. You're adding at the same time, so it's a straight line. Exponential was geometric. You're timesing, so it's a curved line. So if I look at 1 and 2, what one looks most like a straight line? What looks most like a exponential? Because that line of best fit can be more than just a straight line. So if I look at 1, looks like I could probably draw a pretty good exponential right there. So an exponential would be the best. Okay, and number 2, it looks pretty good as a linear, so something, oh, that wasn't very good. Like this maybe. And that's going to be our linear. So you're going to draw a graph, best way you think, that kind of splits all the points and follows that model. Okay, on this one you're doing the same idea with a scatter plot. So we plot the points. So we got weeks, we go up to 20. So we're counting by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Money and savings, we start at 200, and there's probably counting by 10, 20, 30, 40, 50, 60, 70, 80, by 20s. So 20, 40, 60, 80, 100, 120. Well, that's not going to work either, is it? because that would be 280, 260, 240, 220, 200. Oh, that should work. What am I doing wrong? We have 0, 20, 60, 100, 120, 140, 60, 180. Okay, don't know what I did wrong there that first time. But anyway, so at 1, we're up to 200, so right about there. 3, we're up to 175, so it's pretty close to that. 4, we're at 162. Okay, so 175 should probably be a little closer to 180. Okay, then 7. So 7, we're up down to 120, so right about there. Okay, then 10, down to 87. 13, down to 57. And then at 20, we're at 5. Okay? So, correlation, it's positive or negative. Remember, a positive correlation is going to look like this going up. Whether your dots are really close together going up, or they're kind of a little further apart, but they're still going up. A negative is the opposite. Could be dots really close together, or they may be a little further apart, but you can see there's kind of a negative. They're all heading that way. Okay, ours, which way is it going? Down. So ours is a negative. Why? Because as the weeks increase, the money decreases, which makes it go down negative. What would you estimate the correlation coefficient to be? Why? Well, if we look at it, they're in a pretty good line. Remember, the correlational goes from 1 to 0, 0 to negative 1. So this is the positive side. And closer to 0, at 0 it's like a super scattery plot. Okay, not really any, there's no correlation. Okay, at 1, it's like a straight line, positive. At negative 1, same idea, just negative, straight line, negative. Okay, the closer you get to 0, the further out your dots are going to get. Okay, the tighter it is, until the further out you get, the less tight it is together. Okay, so it's between 1 and negative 1. So ours is going down negative. It's a pretty straight line, so maybe like a negative 0.8 or negative 0.9. And we can do these, double check this in class with the calculator, take a look at these and do it that way to see. It says create a regression line. That's a line of best fit. And find the regression equation. Okay, so let's take a look at ours. So I'm going to start up here, maybe at like 210 maybe. Okay, so that's my y-intercept. And then I'll make my graph, and then, we want to figure out our slope, how far we can go down. Okay, to see how I kind of draw it pretty close to that. So maybe right here, if we look at our graph, it's kind of going down. For every 20 we go down, we're going over 2. So our slope would be like a negative 20 over 2, or just a negative 10. Okay, so my equation would be f of x equals negative 10x plus 210. Okay, what does that slope mean? Well, our slope, right, was the y value over the x value. The y value is dealing with money. So negative 20, that's how much money we lose every 2 days. Or if we simplify it, negative 10 over 1, we lose $10 every day, essentially, is kind of what it would be saying. Okay, for most school years are 36 weeks. If the rate of spending is kept the same, how much money needs to be saved during the summer in order for there to be money to last 36 weeks? Well, 36 weeks, each week has 5 days in it, right? So how many days are we talking about? So 5 times 6 would be 0, 3, 15, so 180. Okay, that's 180 days pretty much. So if we're spending $10 a day, okay, that's basically, times it by 10, and you're saying you need to save up $1,800. Ugh. That's pretty spendy, but there you go. Alright, so now we jump to 16. The other ones, you should remember how to do that, function or no, look for the patterns, and tell me what kind. So these ones just want us to say which one looks like it's going to make the best prediction. Okay, so what one models the data the best? Well, it's definitely not this straight line, right? This one kind of stopped when the data keeps going. This one keeps going, so it's got to be that one. I think that's fairly easy to see how it follows that data. Okay, the last couple problems, it says in each problem below an input connected output are given. That's this, an input to an output, and then a common difference or common ratio. Difference, remember, that's going to be linear, arithmetic. Ratio, that's going to be exponential. For linear, we have y equals mx plus b. So we need the y-intercept, where it starts, and the slope. So, start out by making a table. I know that we go 0, 1, 2. At 2 we have 7. And then as we grow, we have a difference of 3. So we're adding 3. So this would be 10. So if we go backwards, that would be 4. That would be 1. There's our starting. And there's our slope. So we go y equals 3x plus 1. And there's our explicit equation. Or you could go f of x equals 3x plus 1. Same thing. Okay, for the second one, common ratio of 2, so we're timesing by 2. So we look at our t-chart. We got 0, 1, 2, 3. At 1, we know that we've got 8 for our output, and we're timesing it by 2, so that would be 16. That would be 32. Going backwards, it'd have to be 4, because 4 times 2 gives us 8. So, with an exponential, remember, it's y equals a times b to the x, where b is the number we're multiplying by, a is the y-intercept. So I'd go y or f of x equals 4 times 2 to the x. Okay? So there you guys go. Hopefully that should answer most of the questions you have. If there's any more, we can talk about them in class. And there we go.